This next PowerPoint will take a look at a transition step between glycolysis and the Krebs cycle. After glycolysis, the pyruvate produced is going to go. The location of the transition step in eukaryotes is the matrix of the mitochondria. In prokaryotes, the cytoplasm. The end result of the transition step will be the production of two high-energy molecules called acetyl coenzyme A, two molecules of CO2, and two molecules of NADH. Remember, the transition step takes place in the mitochondria of eukaryotes, more specifically in the matrix of the mitochondria. The mitochondria is an organelle that consists of an outer membrane and an inner membrane. Inside the inner membrane, there is a space called the matrix, where the transition step takes place. And the citric acid cycle or Krebs cycle will also take place inside the matrix of the mitochondria. In contrast, the transition step will take place in the cytoplasm of prokaryotic cells. During the transition step, the pyruvic acid produced during glycolysis is decarboxylated. A carbon is removed from the 3-carbon pyruvic acid, giving a 2-carbon compound called acetate. The next step in the transition step is an oxidation step in which a hydrogen in acetate is removed and given to a hydrogen carrier, NADH. At the same time, a high-energy molecule, coenzyme A, enters the reaction, producing a 2-carbon compound called acetyl coenzyme A. This is a high-energy molecule. Notice that during the transition step, a 3-carbon compound, pyruvic acid, is decarboxylated, meaning there is a removal of a carbon in the form of CO2, producing a 2-carbon compound, ultimately acetyl coenzyme A. Also notice that during the transition step, there is an oxidation step generating NADH. Now remember that glycolysis produced two pyruvic acids. Each pyruvic acid will go through the transition step. So per each molecule of glucose, two pyruvic acids will be decarboxylated, producing two CO2 molecules, two NADH molecules, and finally two acetyl coenzyme A molecules. The transition step is not considered a central metabolic pathway. Nonetheless, it does accomplish some of the goals of the central metabolic pathways. There is energy form in the form of reducing power. There are two oxidation steps that produce two NADH molecules per glucose molecule. Precursor metabolites are also produced. Acetyl coenzyme A can be used to produce fatty acids for triglycerides. However, there is no immediate energy produced during the transition step. You should now be able to use the transition step to fill the metabolic pathway chart of Chapter 6. You should know the location of the pathway in eukaryotes and prokaryotes. You should be able to mention the starting reactant and the final product, the number of oxidation steps per glucose molecule occurring in the transition step, the number of ATP synthesized per glucose molecule, if any, and the number of decarboxylation steps per glucose molecule.